This is 9.2D in college trigonometry, logarithmic functions. Continuing on with our examples, we're in example number 5 right now. And what we're going to do with example 5 is we are going to write each expression as a single logarithm. So we're going to go backwards. On the last lesson, we expanded. Now we're going to take the expanded and compress it into a single logarithm. So we're going to take something as massive as this, and again write it as a single logarithm. One of the things that's really important when doing this, notice that my log, my base, is a 3 for each one of these. That's one of the key things. If there is not a 3 as a base, or the same number or letter as a base, you can't do any of this. So make sure that's the case, and at this time it will be, because we don't know how to do anything different. So this has a plus sign, so that means these are actually multiplied, right? So I can write that as x plus 2 times x, and this minus means divide. Okay, so there we go. Alright, so example number B, I guess is what it is. We have 2 log a to the m minus 3 log a to the n. Whoops, where's my n? There's my n. Alright, so again, we're going to do everything backwards. Log a to the m squared, so this goes up there, minus log a to the n cubed, because that goes up there. Okay, so I've come that far. And then this minus sign means divide. So I'm just going to write this as m squared over n cubed. So it compresses to that. Okay, so remember we started with this one up here, and we made it look like that. And in the last examples, we took that and expanded it to that. So we're just getting an idea of how to go back and forth a little bit. Alright, let's go and look at C. C is going to be a little bit trickier, but you follow the same rules and you are fine. Plus 3/2. So I know with these fractions that are exponents, I'm going to end up with square roots. That's a B, 2n minus log of b m squared n. Alright, so let's go ahead and put the numbers in front as exponents. And again, kind of hard to write it and make it look like exactly what you want it to, so pay attention to what you're doing. And I figure if I can do this using a pen on an iPad, you should be able to do it with a real pen. So this didn't change at all, did it? Okay, so that's going to stay looking like that. Alright, so let's do this part of it. So we're going to write it as log with a base b again. The bases all have to be the same or you can't do any of this. But in this case it is. They're going to be the same. So we have 1/2. We have 2n to the 3/2, which I should have put these in parentheses in the first place because that 3/2 is applying to that 2 as well. So sorry I didn't do that. Over, because of the minus sign, m squared n. Alright, so now we're going to go ahead and combine what we can. So we're going to try to simplify that top a little bit. My m is going to change to because of these, 1/2 minus 2, which is negative 1/2, or negative 3/2. So I could write it as negative 3/2 here, or I could, which is probably a better idea, to put the m to the 3/2 there on the bottom. And then I've got my 2n that I'm going to put 2 to the 3/2. Boy, I can write tiny. N to the 3/2, and that's still over n. Alright, now I've got these two, so I can take 3/2 minus the 1 that's on there. 1/2 minus 1 gives me a 1/2. So really what we've got here is this is going to reduce to just n to the 1/2. Okay, because those, you subtract that. So that leaves me with log to that. Okay, that does not look very pleasant, does it? 2 to the 3/2, n to the 1/2, m to the 3/2. Probably the thing I'm wondering is, do you get where this came from? We had m to the 1/2 over m squared. And if you remember exponents, you subtract 1/2 minus 2 is going to be negative 1/2, which is negative 3/2. And that negative, it would be m to the negative 3/2 on top, but that negative means that we move it to the bottom and take the minus sign off. So we end up with that. Alright, so let's go ahead and, gosh, keep going. Now one of the things that you notice is that they all have a base, or a denominator of 2 in the exponent. That means that we can rewrite this as the square root, because the base number means we're doing square roots. So that's going to be 2 cubed n over m cubed. Okay, because this just means square root sign. So then I can write it a little bit simpler by putting that square root sign up there. Let's see if I can make some room. Okay, so that's what I have left, is that right there when I put the square root sign on. The only thing I'm going to do at this point is make this an 8 n over m cubed, square root sign on there. So what I'm ending up with, and I haven't been dragging the logarithm with me, I end up with that. So again, if I were to take this and go the other direction, I would end up what I started with. Alright, so let's continue on. Example number 6. Okay, you don't run into an awful lot of these like example 6, but it's just good practice to see what's going on here. They're saying assume that the log with a base 10 of 2 is equal to 0.3010. So if you put that in your calculator, you should get that for an answer. Alright, so now they're saying find log base 10 of 4. So one of the things we have to do is try to get this to look as much like this as possible so that we can plug that number in. So what we're going to do is we're going to rewrite this as log base 10 of 2 squared. Then we're going to take that 2 and put it in front. Okay, and notice what we have. This part right there is the same as that. So that was my goal, is to make it that, so then I could plug this in its place. And just multiply that and get an answer. Alright, what if I have something like log base 10 of 5? Oh my goodness. That's going to make it a little trickier because I've got a 5. I can't just reduce that to a 2. So what I'm going to do So I'm going to change that 5 to 10 over 2. And when I change that to 10 over 2, then I can rewrite it. Now these tricks are not going to just naturally come easy to you. Whoops, minus. It's going to take practice. It's going to take using your book to figure it out. So I rewrote that this way. Okay, now I have that there. Alright, so now I have log base 10 of 10 minus 0.3010 because I changed that from what I had up here. Alright, now next part is this mess here. Log base 10 of 10. If you look back at the bottom of page 407, it says when these two bases are the same, that equals 1. So then I can take 1 minus 0.3010. Now these are contrived, meaning they made them that way so that they would work on purpose as you're trying to figure this out. Okay, so that's example number 6. Alright, and as we quickly sum this up, you're going to use this stuff that I'm going to give you right now in section 9.3, but I want to give it to you anyway. It says when we have an A, and we take, and this is where it gets really weird, we have an exponent with a subscript of x, that is going to equal x. So basically what it's saying is if your base is here, and you're taking the log, and you have this x here, that is going to equal x. It also says that if we have the log base a, and we take a to the x power, that is also going to equal x, because we know that that is 1, so it makes sense then that this is going to equal x. Okay, so just write that down, keep track of it, so that when we come to some stuff later, you'll at least be aware of it. So let me just write this here using a number instead of an a, an x. That equals 10. And that is it for trigonometry lesson 9.2.